am gonna redo this one. Okay. And
we gotta read the chapter.
I didn't know how to do it.
all right. Shh. We're gonna review a little bit about certain things. The tests, you are gonna have a slope field, differential equation, Euler's formula, Newton cooling law, Newton cooling.
Is it Euler's or Euler's?
And what else I'm missing?
Nothing to see it.
I think that's it.
Is that an E?
Oh, logistic, yes.
What is logistic? Oh, the thing.
So we're gonna talk about Newton's cooling law is dy dt equal to k times y minus the room temperature. Yeah, we already did that. So this one we should know, this one we should know, this one we should know. We are talking about the second part of logistic. And the second part of logistic, we are gonna spend some time on it today. And your homework is gonna be pretty much the rest of the worksheet. There was an application for differential equation, and there is a Euler's method. So let's talk about logistic again. And logistic is gonna be based on this equation, which is d p dt equal to kp times 1 minus p over 4,000. Or what one this sorry, p over l. Yeah. Yeah, you can do p or y, doesn't matter. Okay. And yesterday we says yes.
So if we go through that whole worksheet, is that just basically like most similar thing to the test?
Pretty much. Okay. So what happened is this one is also known as P equal to L over 1 plus B e to the negative kt. So this is probably the only two equation you need to make sure you know before you come into the room. Because slope field is now nothing to memorize. Differential equation basically just do initial conditions and plug in, find out the C. Euler's formula, Euler's method is yes.
When do we use these again?
Logistic.
B
is a constant.
You have to know the initial
Capacity in the system and like it's the rate of change.
What?
Like for the logistic function, you have to know both parts of the formula.
Both part of, yes, you have to know the original formula because a lot of time it's gonna ask you this one. This one is just they will show up as well. But basically just make an index card, kind of notice that and notice how to use them.
Yeah, so we have to memorize both. They'll give us a problem in the formula.
So this equation I want to kind of guide through. So this is one of the application questions. So we're gonna go through this one. I mean, I sent you the picture last time. So we're gonna read a question. I don't know what elk look like. Apparently, somebody showed me a picture of elk. Dude, can you hunt elk?
Can you hunt?
Yeah.
You can?
Hunt elk. You can hunt elk.
You really?
They're just really big.
Elk are like they're like massive deer. I think they have like. Is it maybe one in the weird fall?
You can hunt elks. Do they taste good? You don't know? You never tasted it before?
You know what elk sound like?
Oh. I never knew.
They're huge.
They fight with the horn?
Yeah. But that's only the males. They do it to like get females, I guess. Oh, compared to people. Huge.
Bigger than the car?
Yeah, they're bigger than a car.
Oh, okay.
Oh yeah. Next to a semi truck.
Holy shit, that's easy.
Yeah.
All right.
Moose are bigger, bro.
Oh, moose different than elk?
Moose are different than elk. Moose are like much bigger. Much bigger.
All right, never mind. Don't worry about it. So, shh. All right. All right, I need you guys to pay attention. We're gonna go through this question very quickly. Basically, this question has initial condition. The initial condition, you should read it from here. This one should be 0, 40, and this one should be 5, 104. But with that, you can say write a model of elk population in terms of t. So what you're gonna do is you're gonna use this equation here. We're gonna use this equation. We can copy it, and we can paste it here. And then you're gonna say P is equal to L, which is 4,000, which is the top number is the carrying capacity of a 1 plus BE to the negative KT. But rest of them is all using the initial condition. They have to give you two initial conditions here because one if you use to find out a B, the other one you use to find out a K. So population is equal to 40 equal to 40,000 or 4,000 over 1 plus B e to the 0. Well, e to the 0 is 1, so be 40 plus 40b equal to 4,000.
Where'd you get 40?
Why is T0?
40 is the initial
Because the
it'll show these 40.
when it's 0. Oh, we're finding the initial condition.
So 40b is equal to 3960. And B is equal to 99. So by using the first initial condition, we can find out the value of B. So your population equation is getting better because you have one thing, which is 1 plus, well, we have 4,000, right? And we also have 99 e to the negative KT now. Now the only thing we have left is a K. We have to go evaluate a K. Because first of all, we find out B and then we find out the K by using second initial condition because it says after 5 years, the population will change to 104. So be 104 equal to 40,000. 1 plus 99 e to the negative 5 K. Is that okay? Now you can use a calculator by setting this equal to 0 and just graph this part.
So we're gonna be given a calculator for this part?
No, not in this particular part, but I would.
Type of question only be on calculator.
Yes. Okay, but not because the way I'm asking you is not gonna require a calculator. If it does, I'll give it to you. Trust me. And if it does, I will give it to you. I have no problem giving it to you. So you graph it. You graph this part. You look for intersections. Look for x-intercept. You'll find out k is equal to 0.194, roughly. Yeah, it'll be 0.194. Then this becomes your new population equations, which is 40,000 over 1 plus 99 e to the negative 0.194 t. So we answered the question A.
Can you scroll up?
Sure.
Yourself? You did it anyways. Yeah, there you go.
Now, so supposedly part B is graph slope field. Nelly, slope field, you're supposed to graph slope field for part B. They go in through 0 to 40, but we don't have the tools for us to graph the slope field. So roughly it's gonna be like this. Is the graph's gonna be like, says this one is a population equal to 4,000, and this is a roughly to 80. So the graph's gonna be like something like this, and it will go through 0, 40. So the graph is gonna be going through like this, and it's gonna follow, and it's gonna have it's gonna go reach the carrying capacity.
So you should
Mm-hmm.
on your test, how is the question gonna be asked?
I will show you it.
Okay. 0, 40. You're gonna show us what?
I will show you question look like.
Okay. So you're gonna
Okay, but this is just kind of in general, like what do you look at things?
for like when we get it in the actual test.
Yeah, FRQ, you're not gonna have FRQ on this particular question. You will have FRQ on Newton's scoring law. On this question, you will have multiple choice actually. And this is what it usually shows on the multiple choice. But you have to understand what each thing represents. Okay, which thing each thing represents.
Show that we got the math tutoring posted on the Steve Body page. Canvas, so they sent a notification out to the
Well, yeah, you guys are gonna be, that's a lot of work, but you guys will do
We
it.
got, I mean, that's the one.
Okay. All right, so because of this, you can actually rewrite the differential equation, right? Because the differential equation is going to be the Kp, which is 0.194 p times 1 minus p over 4,000. So that will be a differential equation. If you graph this, it will look like this. We'll have a bunch of dots with all the slope fields. And there's only one dot like going to 0, 40. And if you follow a dot, it's eventually going to go to 4,000. K is different. So there is a inside, you will have to find a value of B first. This is a B first. Once you find a B, you gotta find a K. Once you find a K, you can actually convert this to the original equation. I just replaced the K with 0.194.
B is not the original equation.
B is not an original equation, no. B is a constant after you plug in initial conditions. Okay, so with that being said, if they say happen after 15 years later, so all you gotta do is plug in 15, so be P equal to 4,000. So 1 plus 99, we find a A, which is, we find a B is 99, 0.91, or 194, sorry, 194. And you can times by 15 here, and this should end up to be 626. So you now, with the two initial conditions, first initial condition at 0, you can find a B. In the second initial condition, you can plug in, you can find a K. After that, you can plug in any value to predict the
Missing the E.
yeah. So after that, you can predict anything after that. So what happened is a long time ago when it's COVID year, I actually plug in all the data, and I was trying to predict like how many cases in COVID it's going to be. And that was pretty accurate if you have enough data points. And you'll find out that they will plateau into a number, and that's as much as anything. Yes. Yes, because that'll be only way to evaluate for
Then
B.
you can have
Yeah, do we get to have too many variables? Okay. Is this okay? Guys, I need you to put your phone away. I think the phone is becoming a very big distraction in this classroom. And either you're on Clash Royale or you're on texting or you're, I don't know what kind of game you're on. Or okay, so the part D as a limit x t approach infinity. What will happen if t approach infinity? If I have a p equation that says 4,000, it's a 1 plus 99 e to the negative 0.9194 t. So if limits as x approach t approach infinity, what will happen? It will not become 0. It will become 4,000.
Yeah.
Because this part, remember this part here, it's going to negative infinity. E to the negative infinity is going to be 0. So then 99 times 0 is going to be 0. So therefore it's 4,000, which just makes sense because every time you have logistic function, if you approach infinity, it should eventually reach carrying capacity, which is that's the maximum population that you can have in this certain situations. Got it? Okay. So hopefully you understand what this K mean and what does this mean, and this is the time, and basically you just know how to use that equation on your AP exam. They will always have one logistic function on AP exam, and it's always on multiple choice. It's not on anywhere else, and it's probably gonna be the one on non-calculator, surprisingly, but I'm not entirely sure. So that will be one thing that you have to know for the AP exam. The second thing that's gonna be on AP exam is I would like to show you a movie.
Is it gonna be?
No, we're just gonna watch one clip.
Is it gonna be Karate Kid?
No.
Are we learning anything after today?
Yeah. Why?
Learn something on Monday?
No.
So we have Monday to review.
So Tuesday is your test.
Yeah, so we have Monday to review.
Yeah.
Are we gonna learn anything new before Thanksgiving break?
We will learn something old. Whatever on AB, I'm gonna try to cover whatever on AB except the volume. Volume, we can cover the first week when we come back from Thanksgiving, including shell method. And then we're gonna go trig substitution and the partial fractions and trig integrations. That's all new. That's all BC. Okay, so what we're gonna do is watching this movie, owning clip of it. Okay, so this is
Febreze.
one-
When you host, your bathroom can feel like a revolving door. Keep things fresh with Febreze Bathroom. It's an outlet-free air freshener that fights odors for 45 days. So even after every flush, you know your bathroom smells amazing.
The problem is when the capsule moves from an elliptical orbit to a parabolic.
So how many of you guys have watching this movie before?
I think
You never seen the movie?
it's on TikTok.
Oh, I show you the clip.
Yeah.
When? Huh?
Wait, but I forgot about it already.
Okay, so I don't remember I go over Euler's method last year though.
I think I learned it in some other.
All right.
You don't know early.
Okay, so this is a movie clip. It's basically Ian was talking to me. Says he kind of explained to me how this works. Is basically is what happened is whatever the shuttle is coming back to Earth, when they go through the atmosphere from elliptical orbit to a certain other orbit, and they have to find out how is they gonna move, like how is the motion, how is the position is gonna be different. So this is what it's talking about. This so this is saying
orbit. There's no mathematical formula. The capsule moves from an elliptical orbit to a parabolic orbit. There's no mathematical formula for that. As we can calculate launch and landing, but without this conversion, the capsule stays in orbit. We can't bring it back home.
Maybe we've been thinking about this all wrong.
How's that?
Maybe it's not new math at all.
It could be old math. Something that looks at the problem numerically and not theoretically. Math is always dependable.
For you, it is.
Euler's method.
Euler's method.
Yes.
That's ancient.
But it works. It works numerically.
That's it.
Let's type it up.
We didn't launch the moon. It was
We launched to the moon. I forgot one word, 2 letters.
All right, so why is Euler method works, and the Euler method is not something new. We learned about this, especially in AB just now. We learned about linearization. Linearization is use equation tangent line. So Euler's method is actually not something new. It's actually use equation tangent line with multiple iterations. What I mean by multiple iteration is, let's just say, for example, I don't know if this is true, but I know it's the other way around. It's when the shadow is going like elliptical here, like this, going around. It's going around from here. Oops, sorry, my bad. Not seeing that. It's going around the Earth like this. This is called elliptical orbit, and eventually it's gonna come back and becomes a parabolic. It's parabolic. So eventually it's gonna come in like this, and it's gonna go this way. So it's gonna have to come in the orbit. So you don't know where. How does it come in, because we don't have equation for it. Well, they never successfully done it, so there was no data point to establish, right? Or I'll give you another analogy, probably a little bit easier to understand. Is imagine that I think this is my analogy. Just think about what kind of situation can happen. Let's just say if I really have a rocket, right, and this rocket is gonna go up, and this rocket has a phases, right? They will have, I think, going to a certain point, they will let go one part, and at some point they will let go another part. But just think about it. Each time they let go something, the weight is gonna be different, right? Or every time burning the fuel, the weight is gonna start reducing. But are you still going the same speed with different fuel? Because the weight is going to be different too. Also, when you go into a atmosphere, the pressure is different. So there's a lot of parameter can change. So the only way is going through, there's no specific formula for it. You have to go through approximation each stage. So therefore, you kind of had to do, like just say if I have something that's trying to go into the orbit, I hear, we're gonna base on this slope to get to here, and based on the next slope to get to the next point, because we don't know what exactly is gonna go. So now there's AIs can calculate those for us. Before, we are not able to calculate this by hand. Okay, so the only thing can do is a very small iteration of the approximations. So let's just try to do a questions here. And what we're gonna do is we're gonna look at a slope field questions, not slope field question. So your homework is gonna be based on the applications. So those application, those Newton's scoring law, there's things like that. But and then we're gonna go to look for the one with Euler's method. Okay, so this is Euler's method. How did I delete it? Okay. So now we have a differential equation, and we have y equal dy dx equal to x plus 2, y equal to 0 is equal to 3. So imagine that I have this function, right? And I have 0 is at 3. So this is 0 comma 3. And some type of dy dx is going to go through there, is equal to x plus 2. And there's a bunch of slope field, and something is probably going to keep on going up. We want to approximate what happened when y equal to 1. So yeah, if we do one iteration from the equation tangent line at 0 comma 3, you can get it. But unfortunately, they didn't say using one iteration. They say using Euler's method and with the 2 equal steps. So what will be the equal step between 0 to 1? 2 equal steps. So what will be the first step going to 0.5? And second step is from 0.5 to 1. Does that make sense? So basically just establish a equation tangent line. And the way I kind of establish it to make it easier, I mean, there's a formula, and the formula is the same idea, but I think it's actually just understand that there's a x, there's a y, and there's a dy dx. Right? Now the first point is at 0 comma 3. Is that okay? But then the dy dx is equal to 2. Because if I plug in the 0 for x, that's equal to 2. Is that okay? But the 2 iteration part is, well, we're going to use 1/2 now. Because we're going to use 1/2. And we're going to figure out what a y is. And we're going to figure out what is a new dy dx. So with the first one, my equation tangent line is y minus 3 equal to 2 times x minus 0. Is that okay? Brandon. Now, what is the first point I'm going to be using? I'm going to use 1/2. I want to see, eventually I want to know what happened with 1. This is what we want to know. What happened when x is equal to 1, but we're going to start at half. So can I just plug in half here? So it'll be y minus 3 equal to 2 times 1/2, and y equal to 1 plus 3 is equal to 4. So that becomes 4. Is that okay? And we know dy dx is what? Dy dx is equal to x plus 2. So therefore is this one's 5/2. But that becomes a new slope because the slope changes when you get to there, get to half. And now I can do an equation tangent line again, but it's based on new x and y value now, not the old one. Because you base on a new situation. The new situation is going to be y minus 4 equal to 5/2 times x minus 1/2. Is that okay? So what we're trying to predict, we predicate what happened is 1, right? So this would be 5/2 times 1/2, y minus 4. So y is equal to 5/2. No, 5/4, sorry. 5/4 plus 4. So it'd be 5.25 or 5 1/4. So that we know at here is gonna be 5 and 1/4. And that's the value we're looking for. We're using 2 steps to get there. Can you use 4 step? Yeah. You're gonna be 0.25, 0.5, 0.75, and use the 0.75 equation to get there. But each one, they all have individual x and y values. Huh? Yeah, just because this is an approximation. Because you gotta understand what they're saying. They say when the things coming back from an elliptical to parabolical, there is no equation. They don't know what will happen in this part. So they have to base on the each thing. They have to build on a different slope. You have to build on base each thing because we don't have formula for it. So we have to have an approximation for that situation being happen. It was useful at the time. Probably for now, there's a way more advanced formula, but that's the beginning stage.
I mean, they would just have to break it up into so many small pieces just to be like integrated.
Yeah, but ideally, we only have. Ideally, that's yeah. My thing is, I actually never learned about Euler's method. I'm gonna be honest with you. I was dumber than you guys. I was never take BC. I was taking AB. I take Calc 2 in college, and we never had to deal with Euler's method. I never had to deal with it. I always deal with linearization. That's it. And I never had to deal with slope field either. This is I don't know why AB teach slope field. We actually talk about optimization, related array. We never talk about slope field because student cannot do optimization or related array. So I guess they put slope field in there. But slope field is actually only belong to differential equation, which is actually the year after Calc 3. But anyway, this is your homework for those 2 worksheets. Euler's method. Okay, Euler's methods right here. There's the answers. Some answers are kind of off, so you gotta be careful. I don't remember which one's off. And the other one is this one. Differential equations. There is a Newton's cooling. Okay, I think that first question will be a good question to put on a test. Yeah, so that's it. Have fun till Tuesday. Hi, Panisha. She's not watching.